Hey then, welcome to this workshop on data cleaning with R. My name is Valentine and I'll be your instructor. In this workshop, we're going to follow the structure. We'll start learning about the learning outcomes, get to learn about what data cleaning in R or with R entails, get to learn about those concepts that we're going to be covering, and then why we actually perform those concepts. After that, we'll go through a practice session. It might take longer than 60 minutes. But depending on the learning pace that you might have. So we'll go through that, and that section might entail, will entail us introducing to you each and every concepts in relation to data cleaning with R. We'll get to provide you with examples of R code with regards to the concepts, as well as the challenges that will allow you to fully practice and be able to put into practice now the concept itself. So then after we'll talk about the next steps. Starting off, by the end of today, we expected to have achieved these learning outcomes. We should be able to understand the significance of data cleaning in analysis. We should be able to clean and pre-process data to make it suitable for analysis. We should also be able to validate data quality and integrity using R, and be able to develop strategies for effective data cleaning and transformation. So what is data cleaning with R? So this is a process that we would normally undertake before performing further analysis, and this process entails identifying or correcting errors within a data set, as well as inconsistencies. Maybe you might have outliers or missing values within a data set that make the data set not suitable for analysis or for creating reports or creating dashboards, because the implication would be that you'd get wrong insights as well as recommendations. So that process just involves ensuring the data set that you're working with for analysis is in the right shape. We can use so many tools. We can use Excel, we can use R, we can use Python, we can use quite a number of data related tools. And for our workshop today, we're going to be using R. R is a programming language that we can use when it comes to working on data science projects. It's quite popular within academia, and we would normally use it generally for statistical analysis projects. But again, we can always use R for data analysis work, such as maybe creating reports, data analysis reports, for even creating dashboards or visualizations that would be published maybe for print, or even just for other purposes. It could be for just different purposes. So R is generally one of those popular languages that will come in handy. So if you get to learn how to clean data with R, you can work with it for even creation of machine learning models. A good example of data cleaning with R, this process that one would undertake, would involve, say you have a data scientist in the telecommunication industry, and they would use R to clean and pre-process a data set that pertains to maybe customer demographics or service usage data. And the idea would be that they would perform the specific techniques. It might involve handling missing values, they might handle duplicates, might transform the data types, and the result would be a data set that would be clean enough for them maybe to perform something like customer, determine which customers are going to churn. By churn it means just leave a product, and as a result they can provide insights, and they can provide recommendations which would be drawn from insights from the clean data set. So generally, stakeholders involved in this data cleaning process are many. Could be data scientists or analysts, could be data engineers who would create what are called data pipelines that would collect data from different data sources, and maybe they could clean that data and then store it in another database that other stakeholders such as data scientists or analysts can pull that data from. It could be business analysts who would clean data to ensure that they have data that will allow them to come up with insights that would be close enough for their recommendations. Could be database administrators, could be IT professionals. So there are various direct stakeholders. There are other indirect stakeholders. There could be maybe it could be maybe business stakeholders who would benefit as a result of the recommendations that they would get from these direct stakeholders. Why do we perform data cleaning with R? There are various reasons. Data quality assurance, there is improved decision making. We can be able to reduce errors and costs that we get. So if we are able to apply data cleaning techniques before we store data somewhere, we would ensure that we have used less space. Maybe we discard data that we don't need and store data efficiently with various constraints in a data source. Then it would be it could be a good strategy. We would even be able to have effective reports. We could actually end up having reports that actually relay the insights that we get from a data set. So if we clean data, we have data that is representative of the actual population or the users. Again, efficient data storage, I've already talked about that. So these are the concepts that we're going to cover: data importation, data type conversion, so converting data types for different columns from one data type to the other, handling column names, duplicates, string manipulation, transformation, missing data. So these are just the concepts that we are going to get to cover in this workshop. We won't cover other workshops. There's extensive workshops. We can, there are extensive concepts that we can work with, but we are focused on these concepts because of time. And concepts like maybe missing data, you can even have a separate workshop for, depending on the use case. So we even have a missing data workshop with regards to Python. We haven't done one with R, but there's so much that we can do. But we just decided to create a workshop that's scoped to these concepts, so that you're able to apply those concepts on any sort of data analysis project that you might have. So any data science project that you might have, be sure you can apply one of these concepts. And once you learn how to apply these concepts, learning about others won't be that difficult. So yeah, those are the concepts. So the next thing that we're going to do is now to go into our practice work. We can work with R in two ways, either locally or we can work with R on the cloud. So our focus for this workshop would be to work with R on the cloud for ease of learning. So we are going to require you to go to this website. Just type in posit.cloud on your machine, and you should end up to this particular page that you're going to see on your screen. So this is RStudio is a tool that we can use locally. So when we're working with R, we normally work with RStudio. We can work with R locally or in the cloud using and using just different services. But on the cloud, we have posit.cloud, which is provided by the creators of RStudio. So we're going to be using that. So once you get here, just click on Get Started. If you're a new user, then choose the free forever option, then sign up. And then once you have, it will take you to this other page where if you sign up, you end up to the dashboard page. So just pause the video. That's the beauty of live streaming. Pause the video, sign up, and log into your dashboard. All right, so once you have signed up and ended up here, this is a dashboard. We are going to create a new project. So click on New Project, then New RStudio Project. It should open now and prepare a new RStudio instance. And we can start by just naming the project that we want to work on. So data cleaning with R, could be capital, just data cleaning with R as RStudio opens. So RStudio might open like this. It could have this tab open, so you could always click on here to just minimize it so that you have maximum working space. And also you can minimize the header by clicking the very top. So I'll just maximize this. So we have different just panes or sections within RStudio. We have the console, terminal, and background shop section. Here we can be able to see the background, the installations that we would have within our computer. Here we have terminal. We can be able to interact with the computer or the project, where we can be able to interact with the instance that or the file directory where our project is located within posit.cloud from here. So if you type in Linux commands, you should be able to apply those commands here. We can be able to run our commands here. There's another window that will pop up here that will be a code editor that we're going to work with. Here we have environment, tab, history, connections, tutorial. We won't use these ones as much, but this one would display variables that we run within our editor. Here we have our files directory. So that's just a quick overview of what this environment entails. The next thing that we need to do is to now upload the files that we'll need for our practice. So we'll upload them into this particular directory. So files, within this files tab, we're going to upload our file there. So in the resource, in the description section of this video, so on the YouTube section, just click on the resource link. There's a resource link. Click on that link, which the link will take you to this page where you can download the document itself. So you click on this link and it should open a new window, and you can download the document. So I'll just download it to be a sample practice document. So once it downloads, then you can get started. You'll get a sample practice, but for those who want to practice extensively, we have more resources. So you can click on get started or just sign up, and you can be able to, of course, we usually charge a membership fee. You can be able to have the resources that the extensive resources that you will need. You'll get challenges that won't be given in this workshop. You'll also get a sample solution or sample solution notebook or a solution workbook that will give you solutions to the challenges that you'll get. So let's download that and then uploading it. So once you've downloaded that, to upload you need to come here, so you can follow the steps. Upload, then you select the file that you have downloaded. So it's a sample, so which is the sample here. I'll also upload those other full files that one might have if you're an Afterwork member. There's a practice. The practice is just a copy of the sample, only that it has more challenges. There is solution workbook. Then we can continue. So the first thing that we need to do is to once we have uploaded them, we can click on practice workbook. But if you don't have the practice workbook, just click on sample workbook. Should open, and then you can see the editor has opened over here, and we'll be prompted to install R Markdown and Tidyverse. So click on install. You'll see in the background job section, it will continue installing. You can give it a second. So here we have the actual code that is for the sample workbook. It's written in Markdown, and we have the sections that have these marks are what we call chunks. This is where our code would be contained. So yeah, so let's once as it continues, we can also view this workbook differently, just clicking on visual, and you should be able to view this workbook visually in a good way, so in a way that is appealing. So let's do that as that happens. And again, if I'm too fast, feel free to rewind the video. That's the beauty about live streaming, and you can just follow through again, just in case I was too fast. So you can see that the editor here is a bit crammed on one section, so we can minimize this section as well as move this section to the right. So at the very in between, you can always just move it to the right so that it's a bit bigger. So so let's get started. The first thing that we need to do, we've installed tidyverse in our Markdown. We can just import now tidyverse so that we can be able to work with it. So we've imported it. Then after that, we can import. Now we're going to now learn how to work with now the different concepts. There are about seven of them, but we'll get to learn with each one of them. As mentioned, if we are too fast, feel free to ask questions. So data importation, which is the first concept when it comes to working with data, we import data into the environment that we would want to work with. So we are working with RStudio, we'll import that data and then perform other analysis. For now, what we're going to do is to import the data. So to import the data can come with different formats. Data can come in CSV formats. It can come from TXT files, but one of the most common formats is CSV. So how to import data using tidyverse, which is the libraries packages that we're going to be working with regards to R, is to use the read CSV function, and we pass two parameters. The first one would be the location of our file. If it's locally, we would upload the file here and then just reference that file using the file name. So we import that, we define that in quotes, and then we add another parameter, which is show call types, which is equals to false, and we store it in sales data. But the reason why we define this data, this particular parameter, is because if we do not, we will get output more information about this, some metadata about this data set, which we may not necessarily want. But we can do that. Let's just first of all run this cell. So we'll click on this icon to run. We've imported it. In the environments tab, you'll see sales. It's a variable. And then it has been imported. So we have stored this data set inside this sales data. We use the left assignment operator to store data, to store a value inside a variable. It's more like how you use =sign in Python. So we run that and we should be able to have stored that there. So once we have done that, let's even remove this to just showcase. We can even turn this to true. By default, actually, this is usually true, but we can even just remove it and see what happens if you run without. And you can see we have some more information about this data set. Like we have, it tells us which variables, which columns that are in our data, in our data set. Tells us even the data types, and yes, some more information about what separates the columns. That's a delimiter, how many rows there are and how many columns there are, etc. But sometimes we don't want that. We just want a clean, let's say, because what's outputted here, you may not want other users to see. It may not be of use for users or stakeholders, maybe other data analysts. So yeah, at this particular point, I had shared the solution to this. Let me remove it. Work on the challenge, and then once you're done with the challenge, you can unpause the video. So pause the video, work on the challenge, and once you're done, you can unpause the video. If you're an Afterwork member, just know that you can be able to verify the solutions. By the way, I can even just share the solutions for now. In the future, I won't be sharing. I'll just click on the solution workbook. So visual as well. Yeah, so challenge 1, work on that. Once you're done, then we can continue. Okay, this is a solution to the first challenge. So this is the solution, as you can see here. You can pause the video, by the way, and review the solution if you're not sure about it. Okay, moving on, second section, data type conversion. So when we are working with data types, so data sets usually have, especially relational, the ones that come in CSV form, they come in a tabular format where you have rows and columns. Columns, we refer to them in some instances as variables, but they by default have what are called they're called data types, which are just classifications that we give to those columns. And those classifications allow us to perform other operations later onwards. Maybe if you wanted to multiply maybe one column by the other, then you can you would need to ensure that the data types of those two columns that you're multiplying are in a numerical nature. So it could be integers, it could be floats. Floats are just decimal points. So you need to ensure that you do that, because sometimes data types, you might want to maybe not just multiply those values, but you might just want to bring them together, which is what is called concatenation. Instead of multiplying, you might want maybe to bring those values together of those different columns. Let's say, for example, you have a column called first name and another one of last name. So the values, you'd want just them to bring them together and put a space in between. And you call and you have a new column called full name. So data types, in such a situation, you need to ensure that the data types that you're working with are of a textual nature. So in R, we usually have char as the data type for that. So let's see how we can convert from one data type to the other. So if we wanted to convert from text to integers are whole numbers, we usually use the asInt function. So first of all, we load our data set. So once we have loaded our data set, by the way, we can also display the data types for this data set, still by changing this to true. This will give us the extra information that we might have. So this tells us this is CHR, means just a character. This is a double. So these two have just textual data. This has numerical data. It has decimal point data. So here in our case, we want to convert quantity from double to integer. So, but we can also get the data type information by saying str, then using the str function, then say sales data and run that. And you should be able to see we have, okay, we are getting this because this is, let me change this to false. So we can see that we have numerical data type, but we'll still get the same thing. Actually, we can still use, we can still use the same, but yeah, still we use this. So we would, first of all, this is the variable that we want to store now the data set that will contain our new data type for the column that we want. So we say sales data. We use a pipe. This is called a pipe to apply the operation that we want, and we use a mutate function to create a new column. So inside it, we define the new column name, and this new column name should have the outcome of now this particular operation. So we want to convert quantity as integers and store those values there. And then once we have done that, we can now just print out this information about the data types. Here we have, you can see int, and from num to int. So we converted to an integer. So at this particular point, pause the video, work on the challenge, then we can continue. This is a solution to the challenge. You don't have to have quotes, but you can always have those characters, especially when you are working with column names that have more than one word. All right, integers to float conversion. So sometimes you might want to convert maybe from, we've converted it to an integer, maybe from now of an integer to a float where you have decimal points. So let's first of all run this cell. So we have num. So we want to convert quantity and sales price to float. To float, we would use as numeric function, and we specify which columns we want, and we store them in those values, and we preview our data type. So technically, they're already in double. So it's still something that you could always explore, but you could also try, converting again what you have here into into a float. All right, pause the video, work on the challenge, and then once you're done, we can continue. So this is the solution for that particular challenge. All right, moving on to column names, that's section 3. There are various operations that we might want to perform when cleaning a data set. We might want to not only ensure that the column names are in the right shape, but we might also want, and by that it means might ensure that we might want to ensure that they have the right data types, but we might also want to extract the column names, perform some operations on those column names, maybe do some replacement of some values, maybe replace spaces with underscores. And this is what we are going to be learning, how to just pre-process column names. All right, so to get column names, which is what we're going to learn first, we can be able, first of all, we just read our data set. We're going to be reading different data sets. So we read, working with different data sets. So we are going to be reloading different data sets. Let me just go back again. So here we have this data set. We're going to load it and store it in sales data. So we're going to overwrite what the other variable that we had created, the sales data variable. Then we use the call names function to get the column names, store them in call names, and preview the columns themselves. All right, so those are the column names that we have. Just all right, so at this particular point, pause the video, work on this challenge, and then once you're done, we can continue. This is the solution to the challenge. So yeah, this is the solution to the challenge. Okay, moving on, we can also rename columns. So this operation allows us just to change the names of the columns in the data frame on the data set that we are working with. And generally, we can then use those names we can reference those names easily afterwards. So let's first of all preview those columns. So we'll run this chunk. These are the column names. Then we can use the rename function. So sales data, this is where we want to store our data set. We want to apply this operation. We rename customer ID to customer ID, first name to first name, last name, etc. And then we get those column names. We preview those column names, the new ones that we have, which are the ones that we have here. All right, so pause the video, work on the challenge, and then once you're done, we can continue. So this is the solution to the challenge that you can see. So renaming columns, this is the solution to the challenge. Moving on, duplicates. So duplicates, we can be able to check whether our data set has duplicates, so we can get those duplicate records. Because sometimes, we don't want duplicates. In many times, not sometimes, we don't want those duplicate records, and in many times we just want to delete them, or we can just investigate them further, or just once we've investigated that they're duplicates and understood that they're duplicates, then we can take further actions, such as maybe delete them, or take some other action, maybe change a few things with regards to those columns that the records that we have, or the columns values for those records. So if we wanted to get duplicates maybe by specific columns, so we would use the group by function. First of all, we would group our data set by the name column, email column. These are the columns that we would use to determine that our records have duplicates. Like if the columns share the same values for these columns, then we would term them as duplicates. Then we filter them where we have records greater than 1 for columns, or for records which have these column values similar. Then we display that. But again, we can just decide to define duplication as having columns or having records with all values in the columns similar. So we would use group by function, then we'd use across and everything function to define that our duplicates have column values that are all the same. So for this particular case, let me first of all, I'll copy this separately. Okay, actually, we can just work with them. Let's run this. We can even just say cats. It's a way of just printing. You can also use a print function for that. Cats want to print out duplicate records. We also want to print out or duplicate records. So okay, it's a list, we can't print it out, so let's just display duplicate. We'll just change, okay, an easier way is just to print out cat. So let's do that. Let's duplicate records. So these are the duplicate records, but we can also do the same thing for all duplicate records. So yeah. All right, so yeah, so that's how we get duplicate records. Pause the video, work on the challenge, and then once you're done, we can continue. So this is the solution to the challenge. So this is that solution that we need to work on. All right, moving on to the next section. So if you wanted to remove duplicate records, so we can use the distinct function. So we apply it to sales data, and we would get the duplicate records. So if we run this, we should be able to get the duplicate records. These are the ones that are duplicate records. No, these are the cleaned ones, sorry. So we actually are getting the distinct records from the data set, which would not have duplicate records, and we are getting them generally. This is how so that's how we are getting them. So yeah, pause the video, work on the challenge, and then once you're done, we can continue to the next section. So the solution to this particular section would be what you have here. All right, moving on, we are now going to go through how to perform string manipulation. So how we can be able to apply preprocessing techniques to generally columns which are of textual nature. So so how do we go about it? So we'll start learning about how to concatenate columns, which just means bringing columns together. And how do we do that? So let's learn how to concatenate, like bring two columns together. Maybe you might want to bring in maybe name and email, and have full name or as an example. But this is just an example. This is not what needs to go. Let's load this data set. We can even change this to a better one. So we have name and email. So instead of saying this is full name, we can change it to maybe details and separator, which will be separating both column values. So we separate that as that, and we have John Doe, email, phone number, and then you can see details, comma, John Doe. So this is the one that we have. So we just simply use the mutate function and we defined the column, but we can remove also those characters, the limiter characters, that's what they're called. And use a paste function to bring them together, to define the columns that we want to concatenate, and then we separate them. We define the separator, column, commas, and space. Splitting a column allows us to separate a single column. So here we were concatenating. By the way, you might not be able to get the challenges because the challenges are only available for the people who are Afterwork members, but feel free to consider again becoming an Afterwork member, but you can also follow through. So this is how we can be able to do that, and you can pause the video if you're an Afterwork member, work on the challenge, and then we can continue. And you can verify your solution in the solution with the solution workbook. So we can split a column at times if you want to maybe extract information from a single column. So you might want to extract or split a single column into multiple columns based on maybe a specific delimiter pattern. So for example, you might want to split maybe phone number into just different sections. So for example, we can split a phone number, this phone number column, into area code, which is the first one, prefix, and then the number, the suffix later. So then we define how we separate, we split, what we use as the character to split those particular columns, those particular texts or characters, those particular characters. So we use the separate function to separate the data that we want to the column that we want. We define first of all the column that we want to split, then we use into parameter, and then we specify this is a vector and the new columns that we want to create, and then we specify the separator parameter and define the character that separates the phone numbers, and we run that. We can be able to see this is what we have. Pause the video, work on the challenge, and then once you're done, we can continue. Changing cases. Sometimes we might want to change maybe a case from customer. Maybe might want to change the text for one column from uppercase to lowercase. So we can use the two upper and two lower functions to perform that conversion. So let's load this data set. So this data set. Yes, it looks like this. These are just some of the characters, but I think this we can use head. Head is much more representative. So this is what we have. So we might want to convert this into uppercase and convert this into lowercase. So let's run this. Uppercase, lowercase. Yeah, that's what we have. So you can see what we can do. All right, pause the video, work on the challenges, and then we can continue. Replacement. So sometimes you might want to replace maybe some text within columns, and we can do that as shown. So we can first of all load our data set and preview it, and then we can replace this shirt with t-shirt. So with this t-shirt, so we use the mutate function again, define this column, new column that we want to create, which will actually replace the old one because it's a similar column. And then we use str replace function to define first of all the column that we want to replace, and then shirt is the old value that we want to replace and the new value, and then we run that. As you can see, t-shirt has been replaced with shirt has been replaced with t-shirt. Pause the video and then work on the challenge, and then we can continue. Moving on, we might also want to maybe transform data. In some instances where we are working on machine learning problems, we might want to ensure that our data is scaled to a certain scale, so that we don't have certain columns being much more important than others, or being considered important, significantly important than other columns. So we can do standardization. So how do we do that? Let's load this data set. There are various techniques. There's standardization and also normalization. Standardization would involve ensuring that the values that we have in the numerical column that we are working with have a mean of 0 and a standard deviation of 1. So if, for example, you can see the scale of these values is so much bigger than the scale of price. This is almost really tiny, and the scale of this is quite large. So you might want to ensure that both have a mean of 0 and a standard deviation of 1. So we scale the data, then we can perform further analysis, such as maybe training machine learning model. So that standardization is one. There's also normalization, which we don't cover here, which involves scaling your data to have a value between 0 and 1. So let's standardize this data set. We use the mutate if function, and we pass it this argument. So is numeric is to mean that we want to perform this operation, the mutation operation, to columns which are numerical in nature, and we define the operation that we want to perform, which is scale. And we have a standardized data set where we're actually performing standardization to everything, including ID. We should have separated ID later, but the ID column. But for this case, this is just for learning purposes. As you can see here, we have tinier values than we had initially. Pause the video, work on the challenge, and then we can continue. Missing data. At times, we might want to ensure that we might have records with missing values within our data. So how can we be able to handle those missing values? First of all, we need to get those missing values and investigate them further, because they could mean something. Could mean that maybe they were left intentionally or unintentionally. Then we can decide whatever action to take after. Let's load this data set that we have here, and missing values are represented as NA. You can see we have 2 missing values. So we've reloaded the same data set again here, which is okay. It's not okay, but you can even just remove it, but you don't have to. How do we identify the missing values? We use the filter all function to filter for all records which have any missing values across all columns. So we use any vars as well as isNA function, and we give isNA an argument of just a period or point to specify that we want to consider all columns, and yeah, so that's how we apply how we get missing records, and these are the missing records that we got from that data set. All right, pause the video, work on the challenge, and then we can continue. So in cases where we realize that the records that we have do not significantly impact the our analysis, if we were to drop them, so if we had 10,000 records and only 1 or 2 or 3 or 4 records and we have understood that they do not significantly impact the overall analysis if they were deleted, then we can remove them. How do we remove them? We can decide to use the drop NA function. So we apply just the drop NA function to the original data set, and then we work with now the clean data. So this particular data set, this has 8. Here we had 9 and 10, which have been removed and been collected. All right, pause the video, then work on the challenge. In some other situations, we might want to replace maybe missing values with an arbitrary value, maybe a 0. So we can do that by simply replacing the NA values with maybe an arbitrary value, which is 0. So in our case here, that's what we have. So we can load our data set, which is still the same old data set. Then we decide we use actually the mutate function, and quantity is the new column, or it's going to replace the old column. So we apply this condition or this expression if there's a missing, there's NA, missing value for this particular column. That's for quantity, we replace it with 0, or we replace it with the old value. So here we're just simply creating a new column that's a replica of this one and replacing the old one. Then we save that in sales data, and then we can preview that, and we should see 10 records, and we have 0 and 0. Lastly, we're going to explore how to perform maybe if you wanted to replace the missing values with mean or median. So let's learn how we can be able to do that. This is still the same data set, but we're going to replace with mean and median. So we calculate the mean by simply using the mean function of that of the mean, and we identify the column that we want to replace to get the to work with, which is quantity, which is the one that has missing values. We calculate that, and what we want to do here, which we define here, is that we want to use the mean values of these values, these records, the ones that have already have values for them. So that's what we use. So if the mean value here won't consider the missing values, it will only be for the records, the 8 records. And then we use, we can still, again, by the way, use the mutate function like we did here, but now we're just making it easy. We reference just the quantity column name, and then we apply this operation where if that particular quantity column has NA values, we replace that with the mean quantity, and then we define the old values, else the old values will be replaced, and that's what we do. So we print the mean quantity in sales data. So we print the mean quantity to define here, this is our mean value, and that's what we replaced here. We can do the same thing with median. So here I put a mean over here, but we can do the same thing, median. We can do the same thing with median. So more like what we did with mean, we calculate the median of quantity for those values that have all values for quantity column, store it here, and then replace it inside our data frame. And our median is 2, and yeah, that's what we do there. And that's it. That's it with regards to this this content, this practice work. All right, so I hope you are able to learn a lot with regards to the data cleaning concepts that we were able to cover. These were the concepts that we were meant to cover, and we've already covered them. If you feel like you would want some more practice, feel free to go back again and refresh and try and relearn them again. Or if you could also consider becoming an Afterwork member and getting the extra practice work to just help you learn more. So in terms of next steps, what we usually recommend after you come from a data cleaning workshop is to now go through a data analysis with our workshop. We have had such a workshop in the past in this channel, so in our YouTube channel, so feel free to also go through that, or a visualization course, because the idea is that you have already acquired skills that will have prepared the data, that will allow you to prepare the data set that you need for data visualization. So that's the recommendation in terms of the next course, the next step. You can still work on projects in relation to data cleaning, practice more, keep on practicing on various projects. That's it for this workshop, this course. If you did love how we instructed this video, if you have feedback as well, be sure to share that feedback with us on the comment section. And if you did like this video or did like this love this learning experience, be sure to give this video a thumbs up, and also subscribe if you'd want to be informed of future workshops. All the best in your learning journey, and see you in the next